Hello, so it's Michael here, and today I thought I would go ahead and do a tutorial on how to make some sort of oxygen supply meter. So I am in one of my test worlds, so technically it doesn't necessarily make sense, but if you're doing something like an underwater game or something on a spaceship, essentially it's like an oxygen tank that you can increase the oxygen level and then have that displayed somewhere on the UI, but also being able to do other things with it depending on what it is you're wanting to do. So for me, I'm going to go on the basis that this is probably going to be something more of a global type of variable, but a lot of the things that I'll be going over today, they could be applied to other aspects of things, such as health bars, stamina, that type of stuff, of which you could always place on the character themselves. So what I'm going to do, I'm going to go ahead and get started. So what I'm going to do is go ahead and just create a new folder. Let's call this one Oxygen System. The system, like so, and I'm going to go ahead and create a new blueprint, and I want to do that as an actor component, and I'll call this one Oxygen System, like so. Now in terms of the oxygen system, I'm going to go ahead and place it onto the game state. So if you don't already have a game state, you can just create a new one and search for game state. So I chose the game state base for mine, which is this one here. There's nothing in it, I've not done anything with it yet, but what we will need to do, however, is make sure that it's being used on the game mode. So if you have a game mode, you want to open that up, and then you want to make sure the game state is selected. Now the reason why I'm going to be using the game state is because there's one created when the level is started, and it has the ability to add components. And adding to that, the game state is pretty easy to get from most places that have access to the world, so have world context. So then we could do things with it. So let me just double check. Yeah, it's the game mode set up there. The world, yeah, that is set to use the game mode, which has the game state. So again, this is just on the world settings. I am using an override on here. If you're wanting it to be more of a global thing for all levels, you can come up to the project settings, and under maps and modes, you can set the default one up there. So that way, if there's no game mode set for a level, it'll always use this default one. Okay, so now we've done that. On the game state, I'm going to go ahead and add the oxygen. Well, I would add it. Is it not showing in the list? It is, but I spelt it wrong. Let me quickly fix that. There we go. Yeah, so I've got the oxygen system on there, and then I'm going to go ahead and open up the oxygen system component, and just to make sure that everything's loading, I'm just going to quick print string on the begin play. And this print string is just to make sure that it is actually being created. Yeah, so on the top left I can see that print string. So with that done, I am probably, well, we're all good to go. If for whatever reason that print string isn't popping up, just make sure that you've got the game state set up in the game mode and that the level is set to use the game. Now, the next thing we want to do is kind of decide how it is we want to actually do our oxygen level. So we're going to go ahead and add a variable, and we'll just call this one oxygen level. Now you kind of have two choices really. You can either choose an integer or you can choose a float. Now I'm going to go ahead and use a float just because it allows for more finer control over the oxygen level. That might not be something you need, so if you only want it from 0 to 0 to 100 with no in between, you could always just use an integer, and you just have to have the whole values. With a float you can kind of lerp a little bit between the values. Okay, so with the oxygen level set, I'm going to go ahead and also set an oxygen max level as well. So this is kind of going to control the maximum amount of oxygen that we can actually have. So I guess in this case, have within the level. So I'm going to go ahead and just set that to 100. Again, you can change these values to whatever you like. Right, so for the oxygen level, I will start and just set that at default 50, so it's 50% essentially, with the numbers I've set here. The next thing we kind of want to do is start by setting up some functions to be able to manipulate these values when we want to. So the first one we're going to do is add oxygen. And what we're going to do is get this, do an add, want to set the value. So we'll just change the name on the input there to be amount. I'm just going to swap these rounds. With it being an add, it doesn't actually matter which way around they are. This way is a little bit cleaner. Right, so in terms of this function, that's what it looks like. So when we go to add an amount, it will add it to the current oxygen level. Now we've kind of set the oxygen level, we may have things in the level that actually need to do something when the oxygen level changes, and they might need to be like hyper aware of it. One of these things will be the UI. So if we have like an oxygen bar, for example, this will need to inevitably update whenever the oxygen level changes. Now generally with something like this, we wouldn't have the UI constantly checking what the oxygen level is, because if it doesn't change for, I don't know, a couple of seconds or whatever it is that's going off in the game, so let's say if it's a health instead, then you're essentially checking for no reason because it's not changed. So instead what we want to actually do is use something called an event dispatcher. Now event dispatchers are wonderful things, and they kind of allow you to be able to know when something's happened on something else. Now this is great because it means that we can do things in the oxygen system, change the oxygen level, and then have a kind of broadcast that something's happened, and then other things that are listening in a way can then do their own thing. So the oxygen system doesn't need to know about anything else, which is great. What we're going to do is go ahead and under the variable section there is this event dispatchers. So we're going to go ahead and add a new event dispatcher, and I'm going to call this one on oxygen level changed. Again, in terms of the event dispatchers, you can have multiple if you wanted to. For now, I'm just going to do a single one that's used for whenever the oxygen level is changed. However, you could make multiple ones for when it goes up and another one for when it goes down if you wanted to. Again, it depends on how much sort of granular activity you wanted there. Now, with the event dispatcher selected, under the inputs, we want to add a new parameter, and that's going to be a type of float. And I'm just going to call this one new oxygen level, like so. Now with the event dispatcher from the details panel there, we can kind of drag it in and we can just do the call option. So you'll notice there are a few in here, but we'll just go ahead and do call, and we can go ahead and just connect that up to the end. And then for the new oxygen level, we can just connect in the oxygen level, like so. Now the great thing about this, now whenever we call this add oxygen function, it will also not only just add the oxygen, but it will also add, it'll also call the event dispatcher. So anything that's listening to it will get broadcast a new amount. However, we do have a slight problem, and that problem is that someone could just get this and just manually set it like that, and that isn't something we want to allow to happen, because ideally whenever there's any modification of this oxygen level value, it should go through the methods that we've set up that call the event dispatcher. So what I'm going to do on the oxygen level, I'm going to go ahead and set that to private, so that'll prevent anything outside of the oxygen system from being able to grab it and set it. And then what I'm also going to do is actually just create a new function called get oxygen level. I'm going to make it a pure function, and all that's going to do is just going to act as a getter function that'll just return our oxygen level. Now the reason why is because with this being a private variable, it means that things that need to know the oxygen level won't be able to get it either. But with the getter function, it adds a nice easy way to be able to do that. Okay, so now that we've done that, just double check where we're at. Yeah, so there's a few additional things we kind of need to do in here in terms of the add oxygen. And that's because we don't actually take into account the max level yet. So what I'm going to do is just add a little bit of space, and I want to go ahead and clamp the float value here, and the max is going to be the oxygen max level. Like so. Now, this itself will function perfectly fine. It'll go through and it'll update the value, and it'll even call the event dispatcher and notify anything else that's listening that it's changed. However, there may actually be occasions where the oxygen level is already at the max level and then the add oxygen is called, but this itself will still result in the event dispatcher being called. Now, in some scenarios, this might not always be desirable because the value itself hasn't actually changed. It's just we've attempted to change it and it's just still the same. So in these particular instances, we may need to address this a little bit differently. So what we can actually do instead is, instead of setting the variable straight away here, we can promote the new variable to a local variable. I'll just call that one new oxygen level, like so. And then what we can do is actually check to see whether or not these are different. And if they are different, then we can update the oxygen level to the new oxygen level. Again, in terms of this particular section here, you might not need this. So it's up to you whether or not you want to include this particular section. Okay, like so. So make sure that's all clean and tidy, like that. And the thing with this itself, with it being an add function, we can technically put in negative numbers, and that would function as well. That's not always obvious, however, so sometimes it can be nice to have a remove oxygen function in this example. So what I'm actually going to do is I'm going to clamp this float, and I'm going to clamp it between 0 and the max level. So this way it'll just prevent any odd numbers that we get in here. So if anything's so not odd numbers, it will essentially prevent any negative numbers. So if anyone tries to do minus negative 20, for example, it'll just get clamped to 0 and then nothing will happen. So with that done, I'm going to go ahead then and actually create a new one called remove oxygen. So this one is going to be specific for handling removing oxygen level, essentially. Actually, what I'm going to do though, I'm just going to delete the one I created there, and I'm just going to duplicate the add oxygen function. And this time, I want to start by changing the clamp here, so the minimum is going to be whatever the max oxygen level is. I'm just going to multiply that by -1. And the max will be 0. And I want to come through here and change the add node to a subtract. This time the order does matter, so I'm going to do it this way around. So that's all fine there. Okay, so that should all be working. So just looking at what we've set up here, just move those up. So we have the add oxygen and the remove oxygen, and there is actually this sort of tail end here in both of the functions that are actually the same. So just looking at what it's actually doing is, all that bit's doing is actually checking to see if the new value is different to the current one, and if it is, it's updating it. So what we can actually do here is actually go ahead and create a set function instead, which allows you to manually set the oxygen level to a specific value. So that's what we're going to do now. So we're going to create a new function called set oxygen. And I've just copied the sort of tail end of the previous function and paste it into here. And we kind of want to adjust this in a second. Now, what I'm going to do is want to add an input, put new amount. So where it says new oxygen level, I kind of want to replace that with that new amount variable. So the input variable, like so. And then if we go to the add oxygen, we can come in and just call this set function. And in terms of what we've got here, we can actually delete this whole end bit and just connect the new amount, like so. And we can remove the local variable as well, as we don't actually need it anymore. So the value actually gets stored as an input variable here on the set oxygen. So we can do the same on the remove. So again, I'm just going to delete the tail end, add in the set oxygen, and we'll go ahead and connect it all like so. So hopefully you can see how with these functions here we've kind of streamlined it a little bit in terms of how it functions. So we've got an add oxygen function, a remove oxygen function, and then just a set function. So that's kind of the four main functions that we'll probably need inside of this particular system. Now, one other thing that we might possibly want to do on here, particularly in terms of oxygen, and potentially other things like health can possibly be another one, and that's add another event dispatcher for on oxygen depleted. So from the context of health, this could be when the health reaches 0. You might want to trigger something specific like a death event. Similarly with the oxygen, if it hits 0, you possibly want something to happen. For this, we don't actually necessarily need any inputs to it, because we don't need to know what the current value is, because if it's depleted, then we can assume that it's 0. You can of course adjust that how you feel fit. Now, going back to the set oxygen function, we can actually come in and check it. So whenever we set it, we can just say, hey, is this less than or equal to 0? It shouldn't ever be less than 0, but it's always good with floats. So if it is, we can then call that event dispatcher as well. Now again, the reason we are using event dispatchers here is because, again, this just allows things to know when things have happened within the oxygen system, and they can then do something without the oxygen system needing to know about it. And in terms of external sources, it just means that we're not having to constantly check the values from the oxygen system, which can reduce the amount of things we have ticking essentially. Okay, so we've got that sorted. Now, I guess one thing we probably want to include as well is possibly some sort of a timer that ticks the oxygen level down. So for this, I'm going to do on begin play. In terms of begin play, depending on what you're doing, particularly if you're doing like you're having some save system set up, you may need to use some other event that you set up that's linked to a save system after some variables have been set. But for now, certainly during testing and things like that, begin play should be perfectly fine. And what we're going to use that for is to actually set up the timer that is going to tick down the oxygen level. So in terms of the function, let's have a little think about how we want to do this. So go ahead and create a new function. This one's going to be called natural depletion. depletion. There's probably a better name for that actually. We'll call that one use oxygen. Again, you can kind of think of another name. But what I'm actually going to do here for the function type under the access specifier, I'm going to go ahead and make that private. And the reason why is because this particular function should only ever be used within the oxygen system as a part of its depletion system. Well, depletion logic. So in here, we essentially want to go ahead and set the remove oxygen. And so for the use oxygen, we want to go ahead and just call the remove oxygen function. But for the amount, we're going to go ahead and promote that to a variable, and this one's going to be depletion amount. And then as a description, and that's the amount of oxygen that is used per cycle. And you're probably thinking, well, why am I using the term cycle? And the reason why is because when we start the timer, we're essentially going to specify how often it will update. So going back to the begin play, we can do the set timer by event. Like so. And for the time, we're going to promote that to a variable, and we're going to call this one cycle duration. I'm just going to set that to 1 for now, so you can just assume that's 1 second, and we're going to set that to looping. And we'll go ahead and make sure that's only max once per frame. If you're using an older version of Unreal, you may not have this option. In terms of whether or not you want to tick that, you may want to have a play around with it. And then I want to go ahead and just store the return value. So this is the cycle timer handle. And the reason we want to store this in a variable is because that would allow us to pause this particular timer if we ever needed to. So in terms of this particular section here, we are almost done. The last thing we kind of need to deal with, and that's the actual event. So that's what this little red dot is here. So this is a delegate, and a delegate is essentially a reference to an actor and the function that should be called. So what a timer does is it adds the delegate to a list, and then when the timer hits 0, it'll then call the actor, call the function on the actor. So in terms of these delegates, we do kind of need to get familiar with them as they are used with the event dispatchers. And you're probably thinking, huh? Because we've obviously called them up here, but we've not actually bound anything to them yet. So that'll probably make a bit more sense shortly. But as a part of that, we do need to make delegates, and there's a few ways that we can do it. So if we're in the main event graph, we can always just add a custom event. And you'll probably notice that it connects with that little red dot there. So that's essentially saying when this timer depletes and gets to 0, call this custom event. So that's certainly one way that we can do it, and you can kind of just add your logic here. Or alternatively, under the event dispatchers section, there is one called create event, which looks a little bit like this. So the create event node allows you to essentially create a delegate. So as a part of this, you can input the object. In a lot of cases this could be self, but you can essentially set up delegates to call functions on other objects or actors. And then below that you then have the signature. So this is essentially the function. As an example here, we have we've got a few options in here. We've got deactivate, toggle active, and use oxygen. When we're setting up these delegates, we have to make sure that the signature matches. And what we mean by signature is we're referring to the inputs on a function. Currently, we cannot create delegates that have outputs. So if there is a function that has an output, we can't use it as a function when we create an event, which is just something to be aware of. In terms of the timer, this expects a signature with no inputs on it at all, which is why the only ones we have are deactivate, toggle active, and use oxygen. So you'll probably notice, you might have been thinking, well, why have we created this use oxygen function when we can just call the add oxygen function? And the reason why is because we wouldn't be able to use the add oxygen function, the remove oxygen function, on the set timer, because it has an input. So with the use oxygen, we're able to specify, well, this is the actual amount we want, and then we're going to call this function. So for the create event, that's what we can go ahead and do. We can just use select the use oxygen function in there. So what that's going to do is the timer will essentially then call the use oxygen function whenever it hits 0. There may be occasions where we may want to stop this particular loop, because currently if we run out of oxygen, for example, what's going to happen is it'll still continually call this remove. Now whilst we do clamp it between 0 and max, so it's never going to get below 0, we're essentially doing checks that we don't really need to be doing. So what I'm going to do is this particular section here, I'm actually going to drop into a function. So I'm going to select it all, collapse to a function, and I'm going to call that one start oxygen depletion. And I'm not sure if I spelled depletion wrong, but I'm sure if I have, one of you will tell me. So this function will essentially create this timer, which we'll be able to do a few extra things with. However, as a few fail-safe kind of things we need to handle, we kind of want to make sure that this is cleared first. So there's already a timer going, and this has been activated. And then we probably want to stop the current timer before we create the new one. So we can go ahead and just do that there. So at the beginning, I'm just going to clear the current handle. So that'll clear and invalidate the old timer if there is one before starting the new one. Right, so okay, so with the event dispatchers, we did create the on oxygen depleted, which will get called whenever the oxygen reaches 0. So we can actually go ahead and do our own thing on there as well. So if we drag that into the main event graph, we get a few additional options, and that's the event and assign. So what we can do is we can do the assign. So in terms of event dispatchers, we kind of get into the part now where we want to start binding to them. Now this is a little bit different to the bindings that you will find in widgets, where you bind variables. Generally they're on tick and you don't want to be necessarily using those ones. But the bindings with event dispatchers are a little bit different, as well, they don't tick. So what this does here, it's going to bind an event to that oxygen depleted, and then it's going to call this function whenever it gets called. So if we go back to the set oxygen, so whenever this gets called, it's going to trigger anything that has been bound to it. So in this case, this custom event here. So what I'm actually going to do is I'm going to do that just before we start the oxygen depletion. And when that happens, I'm just going to come in, just clear and invalidate the timer. And that's just going to stop it from increasing. Just to run through a scenario with you, so let's say the oxygen is depleted to 0. Let's assume it's not instant death or whatever, it's not instantly over. The player possibly has some more time. There might be a scenario where they're able to add oxygen after it's reached 0, and at which point we then want that timer to start up again. So what we can do, if we go to the add oxygen, just after we call the set oxygen function, we can just check to see if that timer is valid. So is timer active? Alternatively, there is is valid timer handle. I'm just trying to think which might be best for this particular scenario. Actually, with it being a looping timer, I'm just going to use the is valid timer handle. The other one, if you wanted to pause it, for example, the other one would still be, that one would return false if it was paused. So it's a little bit different, whereas the valid timer handle is just whether or not it has a valid timer handle. But when the oxygen is depleted, we do clear and invalidate it. So if that ever happens, then this should return false. And in those scenarios, what we want to do is, so if it's false, we want to go ahead and start the oxygen depletion. As an additional thing we could probably do is actually just check to make sure that is greater than 0. So I guess we could do add 2 here, so this and that one like so. There we go, so it'll check, is the oxygen level greater than 0? If it is there a valid timer handle? If there isn't, then it will start the timer, essentially. So that'll handle any scenarios there. Just in regards to this event dispatcher binding that we have here, this itself probably isn't strictly necessary inside the oxygen system itself. And the reason why is because we do have this remove oxygen level here. So similar to how we do it on the add oxygen, we could probably just do something just as similar in there. Or possibly even in just a set, which actually might be a better option actually. Yeah, so actually I think I'm going to do that instead. So what I'm going to do is actually going to, so in the add oxygen, I'm just going to remove the little bit that we added in, and instead we're going to add it here. So in the set oxygen function, we already have a check here where we're checking if it's less than or equal to 0. So we can kind of assume that if it's not less than or equal, it's going to be greater than. So in this instance, we can just check, is there a valid timer handle? And if there is, we can call this start oxygen depletion. So this kind of gives us some extra things we can do as well. So in terms of this bind event here, we could probably just remove that entirely. And instead on the set oxygen, instead just call it up there, just like that. Okay, so that's kind of cleaned things up a little bit. Although in terms of these event dispatchers, we'll obviously be showing you how you can use them in other places shortly. But I think for now, we probably want to actually see if we can test it. So what I'm going to do is just add a print string, and I'm just going to insert it just after this on oxygen level changed event dispatcher, and I'm just going to print the oxygen level. Now we should be able, hopefully, have nothing happen. Okay, and the reason why is because of cycle duration, maybe? Nope. Okay, let's double check things. So let's double check this, so we do have that on there. Okay, yeah, so the depletion amounts, the default value, that is set to 0, so that's the reason why. Let's set that to something like 0.1. Let's see if that makes a difference. Nope. Okay, so let's start doing some debugging. So what I'm going to do first is just check, does this timer actually start? So does it call this function? So what I've done is right clicked on it and done toggle breakpoint. Okay, yeah, so that has called, so let's advance a single frame, so that's this little node here. And we're going to just kind of step through, see what happens. Okay, so it does seem to do that, so that's great. So I'm just going to take the breakpoint off again. Now we do call the use oxygen function, so let's go ahead and toggle breakpoint on that. Okay, so that is being called, so let's step through this one, shall we? Rookie mistake. So of course, the reason we added a remove oxygen function is so we can keep all the values positive, and we just change the operation that we applied to it. But this particular example, I kind of did it to account for negative numbers, which was silly. So on the clamp here, we want to actually move these around. So the oxygen max level should be on the max. So the amount we put in will always be between 0 and the max amount. So we can never remove more or less than that. So hopefully that should now fix the issue we was having there. There we go. So we can sort of see up in the top corner, it is sort of ticking down. I'm not sure how clear that is on the video, but as far as I can see, it's ticking down from 50, so 48.4, 48.3, 4, yeah. So the next thing we want to actually go ahead and do now is possibly look at setting up some UI so we can visualize the oxygen, essentially.